And for section 8.4, I'm kind of combining days 1 and day 2 onto the same homework help. This problem would be a day 1 problem, and then the rest of them will be what we did on day 2. Alright, so we're going to look at finding the determinant of a lot of matrices here. Here's a 2x2 and how to find the determinant. A couple of them where we have a 3x3 matrix, and how do I find the determinant of that one. We get a 4x4 matrix and the steps we have to do to find the determinant for that one. And then a problem where we have a determinant symbol in there and they ask us to solve an equation. So just a reminder, if you don't have a square matrix, you can't find the determinant. So you almost hope that you don't have a square matrix. It would make the problem really quick. So finding the determinant, well, when we did that, finding the inverse of a 2x2 matrix, and you had, if you remember that little formula, it was 1 divided by AD minus BC times, and then we switch some stuff around. That thing is the determinant, AD minus BC. In other words, you multiply those two together, subtract, multiply those two together. So for this one, since it's a 2x2, it's a little quicker and easier. I take A and D, or these two numbers, and multiply them together. So it's 2/3 times negative 1/3. Subtract, now multiply 4/3 and negative 1. So it looks like I end up with negative 2/9 for the first one. It's going to end up becoming a positive 4/3, or you will want to get a common denominator. So we'll change this to 12/9. And it looks like I end up with 10/9. And that's the determinant of that little 2x2 matrix. So 2x2 matrices, quite simple for the most part. Just have to be careful with double negatives. Other than that, you know how to do it. Alright, 3x3, the steps get a little messy. What I need to do is I basically need to break it down. We have two ways of doing this. We have what I call the arrow method, which I'll show you how to do. And I will do expanding by cofactors, which is what we kind of did in class. We did both in class, but the expanding by cofactors is important, especially when you get to a bigger matrix. So expanding by cofactors, remember what you do is you want to pick a row or column when you do this, and you want to pick a row or column that has a lot of zeros in it. So you can do whichever row or whatever column you want, but picking, say, that row or maybe this column makes sense because of all the zeros in it. If you pick this row, it's fine, you'll get the same answer, you just have more work to do is all. So what do they mean by expanding by cofactors? Well, here's what we do. You take the element itself in that position, which is a 1, and then you multiply by its cofactor. So it's in the first row, first column, so I would say it's 1 times the cofactor C sub 1, 1. The next element I have is 0, so it's plus 0 times the cofactor, this is the first row, second column. Plus, the next element in that row was 0 times the cofactor, that's the first row, third column number. And now obviously the reason you want to pick a row or column with a lot of zeros is I don't have to actually figure out what these two things are because it's 0 times that. So it saves me a lot of extra work. All I have to do is figure out what cofactor C sub 1, 1 is. Now remember, when you add these numbers together, if it's even, then you leave this, whatever number this is, you leave it the same. You don't switch the sign, in other words. So what I usually do is, if this adds together to give me an odd number, which obviously it doesn't, what I would do is I would switch the sign on that number, and then I can ignore it. So for example, if I had to actually find this one, this sign would end up switching. And you'll see one like that eventually here. Alright, so cofactor, remember how to find it. To find the minor, which will get us the cofactor, you block out the first row, first column numbers, or whatever these subscripts are, and then find the determinant of what's left. So this is technically 1 times the determinant, negative 1, 0, 1, 5 of that matrix. And so I know how to find the determinant of that. That is just doing negative 1 times 5, so negative 5, minus 1 times 0. And so it's 1, or whatever this number is, times the determinant, which looks like it's negative 5. My answer is negative 5. And the cool thing is no matter which row or column I use when I do this, it will eventually come out to negative 5 if I don't make any mistakes. Alright, so let's jump down to the next one. Going to do the same thing. Now for me, if I were doing this problem, I would say it's going to make sense to either pick this column or this row. Just because it has a 0 in it, it makes a lot more sense. It's less work to do. So that's what I'm going to do is I'm going to pick this row. You can pick whichever row you want. It eventually will work out the same. But since this is it's a 1, it's in the third row, first column, so this would be C sub 3, 1. Even number, so I'm going to leave that sign the same, plus 0, even though I know this is 0, I still want you to write it out. It's cofactor, third row, second column. This is odd, so I would switch the sign. Now this is 0, so it doesn't matter whatever this turns out to be. It's 0 times that. Plus, next element in that row that I chose was 2, and that's the cofactor, third row, third column. And that would add together to give me an even, so I would leave that number just the way it is. So it's 1 times. Now come over here, take the third row, first column, block it out, and find the determinant of that matrix that's left. So it's negative 1, 3, and 4, 4, plus 2 times the determinant of, now block out the third row, third column, and I like doing this, it's easy for me to see it. It's 2, negative 1, 1, 4. And now just find these determinants. I've got 1 times, looks like it's going to give me negative 4 minus 12, plus 2 times, this is going to give me 8 minus negative 1. And so it looks like I end up with negative 16 when I multiply those together. That's eventually going to give me 9 plus 2, or 18, and my determinant for this matrix should end up being 2. Alright, now let's say you want to do the arrow thing that I was talking about that we did in class. Remember, to do this you need to multiply 3 things, and remember when we multiplied doing the little 2 by 2 matrix, we always went that direction first. AD was this way, and then BC was that way. Remember, the book did something like that to kind of help us remember. Well, we're going to do that same idea. I'm going to go diagonally from the top left to bottom right, and I need to multiply 3 numbers together, so I'm going to go diagonally this way. You're going to want to draw your arrow lightly just so you can actually see these numbers. And I'm going to multiply these 3 together. So it's 2 times 4 times 2, or that gives me 16. And because it's a 3 by 3, I'm going to have 3 arrows going this direction. I need 3 numbers, so how I do that is this. I'm going to take this diagonal, which only has 2 numbers, and wrap it around and grab that lone number here, so that I still have 3 numbers to multiply together. And of course, since one of them is a 0, it makes that a lot easier. And then I'm going to do it again for this diagonal. I need 3 numbers, and that's what these 2 will be for. So now I take 4 times negative 1 times 1 and get negative 4. Add all those together to get 12. And that 12 is kind of like the AD here. Now I'm going to subtract. Now I'm going to go this direction, up and to the right. So this is one diagonal. Multiply those 3 numbers together. 1 times 4 times 3, or 12. Remember, I need 3 numbers to multiply together, so this 0 and 4 are going to curve around and grab that 2. So 4 times 0 times 2 is going to give me 0. And then this 2 will curve around and grab the 1 and negative 1. And negative 1 times 2 should give me negative 2. Add those together, I get 10. And now it's 12, the number on the bottom, minus the number on top, and of course I end up with 2. And for some of you, you will like doing the expanding by the row or by the cofactor thing. That makes sense to you. Some of you like doing the little arrow thing. I don't care, whichever one you want to do is fine. They both will work. This little arrow thing will only work for a 3 by 3. Obviously it works for a 2 by 2, but if you get something bigger like a 4 by 4, you have to kind of do this and get it down to a 3 by 3, and then you can do the arrow thing. Alright, let's go on to the next one then, which is a 4 by 4. So like I said, I can't just do the arrow thing for this. It won't end up working unless it's a 3 by 3. So what I need to do is I need to do the expand by cofactor thing. So to make this problem easier for yourself, find the row or column that has the most zeros. So when you're doing this, that should be the row I see you expand by. Not saying that you have to do that, but if you do any of the other ones, it's going to take you longer. And if you're doing this on a quiz or a test, you don't want it to take a long time, so you should be doing the thing that's as quick as possible. If you were to say take this column right here, that kind of tells me that there's an obvious part that you're not understanding how to do this quickly. Alright, so now let's expand everything. It's negative 2, the element, times the cofactor that's in the second row, first column. Notice that this, when added together, is odd. I am eventually going to switch that to a positive 2. Alright, Next number is 0, so it's technically plus 0 times the second row, second column. I don't need to worry about it because of the 0. I still want you to write it though. Plus 6 times the cofactor, this is in the second row, third column. And again, notice that this is odd, which means that 6 is going to become negative. Technically, it means whatever this cofactor is, it switches that sign. It's just easier to switch it on here, that way you won't forget about it. Then it's plus 0 times cofactor 2, 4. And again, I don't need to worry about it. So when I write this out, I'm going to change this to a positive 2. That takes care of the cofactor part. And then I'm looking for the technically minor, I'm just going to call it cofactor. Block out the second row, first column, and I'm going to write down that matrix. So 6, negative 5, 4. And then it would have been 1, 2, 2. And 3, negative 1, negative 1. Plus, remember I'm switching the sign on this, so I'm now going to switch this to minus 6 times the cofactor. Now block out the second row, third column. And that's going to give me 3, 6, 4. And if you're like me, I like actually putting this down there so I'd make sure I get the right numbers. 1, 1, 2. And 0, 3, negative 1. And now you've taken something that was 4 by 4 and broken it down to 3 by 3. Now imagine if you had picked this column, you'd have 2 more of these things to do. So you're just making your life more miserable. Unless you really like doing this stuff, I do, but I still want to do it as quick as possible if I can. Alright, now that I've got it down to a 3 by 3, now it's just doing this. I can either do the expanding by row or column, or I can do the arrow thing if I like that. And I'm going to do one of each just to give you practice with both. So I'm going to expand by row or column on this one. And I don't see any zeros in here, so it really doesn't make a difference which row or column you do. It eventually will work out the same. So usually when that happens, I'm just going to grab the first row. So you can pick whichever one you want. So expanding, that's going to give me 6 times, that's cofactor C sub 1, 1. Even when I add those together, so leave that alone. It's going to be minus 5 cofactor C sub first row, second column. That's odd. So this is going to switch signs. Plus 4 times cofactor first row, third column, even. That will stay the same. So don't forget this 2 is in front of everything, so I forgot to write it there. So 2 times all of that. So it's 2 times 6 times cofactor. And I'll block out the first row, first column. That gives me 2, 2, negative 1, negative 1. Remember, I'm switching the sign, so I'm going to switch this to plus 5 now. Cofactor, block out the first row, second column, gives me 1, 2, 3, negative 1. And then plus 4, block out the first row, third column, it gives me 1, 2, 3, negative 1. And now I can evaluate. So I've got 2 times 6 times negative 2 minus a negative 2, so plus 2, plus 5 times negative 1 minus 6, be careful again with double negatives, plus 4 times negative 1 minus 6. And so I've got 2 times 6 times 0, so that's just 0, plus 5 times negative 7, plus 4 times negative 7 again. And so I end up with 2 times negative 35 minus 28. And this is eventually going to give me, if you add these together, that should give you negative 63. Multiplied by 2 is going to give you negative 126. That is just this part of it. I still need to figure out that. So it's negative 126 minus 6 times something, and now I got to figure out what the determinant of this is. And now again, you can do the expanding by cofactors if you like that, or I'm going to do the arrow thing on here just so you've got a sample of both. So multiplying diagonally down first, multiply these 3 together and you get negative 3. Take these 2, curve around and grab this one number. Since one of them is a 0, it makes it 0. And then 4 times 1 times 3 is going to give me 12. Now if you've got big numbers in here, this maybe isn't the most convenient way if you don't have a calculator, because you're going to get big numbers to deal with. So it looks like the bottom number is 9. Going the other direction, I have 0 times, doesn't matter what those two are, it's going to be 0. I have 2 times 3, so 6 times 3, or 18. And then I have negative 1 times 6, or that's going to give me negative 6. Adding those together gives me 12, and so this is going to end up being 9 minus 12. It's always the bottom one minus the top one. And so now I've got negative 126 times negative 6, negative 3, basically plus 18, or my final answer is going to be negative 108. And that is the determinant of my 4x4. When you're doing the little arrow thing, this is what some people like to do, and you're obviously more than welcome to do this. Because when you're drawing all those arrows, it's easy to maybe run over that negative and then all of a sudden you miss it. When people are doing this, a lot of times what I'll see people do is just do this and then write the numbers here. They won't actually sit and run the numbers through. You could easily sit there and do that kind of on your own if you want to. If you feel like that is neater, then you don't have to mess all those numbers up. That's fine. If you do the arrow thing, please don't do it so dark that when I look at it, I can't figure out what the heck those numbers are. All right, then of course, pulling out your calculator, you can do a lot of this stuff with your calculator. And if it's on a calculator part, you could just type it in. If you want to find the determinant of any square matrix, remember it has to be square, you just need to type it in. So second matrix, go over to edit now, pick whichever one you want, hit enter. This is a 4x4, and the first row is 3, 6, negative 5, 4, negative 2, 0, 6, 0, 1, 1, 2, 2, 0, 3, negative 1, negative 1. And then once you get that entered in, or you could have picked one of the 3x3 ones that we did earlier if you wanted to. Once you get that finally entered in, go back to second, next to the negative first or the matrix category. And this is the only time you use this column, but you're going to use the math column. And you can see that that first one stands for determinant. Now, I maybe didn't mention it when I was going through and doing the notes, but do you recognize that symbol? You see the absolute value around a capital number? That stands for the determinant of a matrix, where here I just asked you to find the determinant. Or I could say find the DET and then matrix, whichever one it is, to make sure you're able to figure out what that means for all of them. All right, I'm going to pick that determinant, and then I'm going to go back to the matrix category and pick the one I want to find the determinant of, which was matrix A here. Go ahead and hit enter, and it'll do all that calculation for you and figure out that, yep, it definitely was negative 108. Obviously, if it's on a calculator part, you can do that. If it's not, then you have to do it by hand. You can easily use the calculator to check yourself if you want to. All right, the last one I have for you is just a problem where you're solving now. So it's going to ask you to solve for x if, again, stands for determinant. So they want you to find the determinant of this and then set it equal to 0. Well, it's a 2 by 2, so I'm supposed to multiply those two together. So it's x minus 2 times x minus negative 3 times negative 1. And then they say set that equal to 0. Well, it won't take you too long to see if I distribute here. I'm eventually going to have something that's quadratic. That's minus positive 3. All I'm really doing is looking at this quadratic. And for us, we're lucky, it factors into x minus 3 and x plus 1. So I know that x is equal to 3 and x is equal to negative 1. And if you wanted to check yourself, you could easily plug that number in. If x was equal to 3, that means I'm finding the determinant of that would be 1, negative 1, negative 3, 3. That would give me 3 minus 3, and that gives me 0. So you can easily check yourself if you wanted to. But there is homework help for section 8.4. If you're having trouble, please come in and ask for help.